This is the first video in a series of videos intended to introduce you to the nomenclature of organic chemistry molecules. We'll start with functional groups and alkanes. To learn the language of an organic chemist, one needs to start by learning the names of the organic chemistry functional groups. The most important of those functional groups are listed on the left-hand side of this slide. Table 3.1 shows representative structures and some molecules that contain these various functional groups. And it's a two-page table. The easiest place to start naming molecules is with the alkanes, the simplest of the organic chemistry functional groups. Start off by learning the names of the C1 through C12 roots of the alkanes. The root is the first portion of the name, like meth, eth, prop, and bute. The suffix, in this case, the ane, tells you what functional group you're dealing with. The alkanes always have an ane suffix. It's also important to know the names of the alkyl groups. It's very easy once you know the names of the alkanes themselves. For example, methane has the meth root, and when it is an alkyl substituent, it's named as methyl. So the YL ending tells you that you now have an alkyl group bonded to something else. For a branched alkane, it's important to first identify the longest continuous carbon chain to identify the root of the alkane. In this sample, the longest continuous chain is a 4-carbon chain, so we know that a portion of the name is going to be butane. After identifying the longest carbon chain, you will identify any substituents. There is a methyl group attached to the longest chain, so we know that methyl will also be a portion of the name. Now we have to say where the methyl group is attached to the alkane. To do that, we number the chain so that the lowest possible number is assigned to the carbon that has the substituent. So we number left to right in this particular example, and that means that we are going to have a methyl group at position 2. To put that all together as one word, we'll say 2-methyl butane. Notice that there are no spaces within the word and that there is a hyphen between the number and the letter. Now here's a case that's a little bit more complicated. Let's give it a try. Remember our rules. We're first to identify the longest continuous carbon chain, and that happens to be here. It is a 5-carbon chain, so that we know that the root is going to be a pentane. We need to identify substituents. I have 2 methyl groups, and so I am going to have dimethyl as a portion of the name as well. And then to number the chain so that the first substituent has the lowest possible number, I need to number this one right to left. The first methyl group will be on carbon 2 if I number right to left, but it will be on carbon 3 if I number left to right. And so let's put it all together. I'm going to have 2, 3 dimethyl pentane. Again, there's no space between the letters, and there's a hyphen between a number and a letter, and there's now a comma between the two numbers, 2,3 dimethyl pentane. There are other substituents that are frequently encountered and are identified by a common name. The isopropyl, isobutyl, sec-butyl, and tert or T-butyl groups certainly fit into this category of substituents. It's important to know the structures of these 4 common branched alkyl groups. I remember these names in that the isopropyl always has 2 methyl groups at the end of the chain. So isopropyl, isobutyl, isopentyl, and so on. I remember that the sec-butyl group is a straight chain alkane, so those carbons are all in a row, and the substituent is attached at a secondary carbon, hence the name sec-butyl. And for the tert-butyl group, it's a butyl because there's 4 carbons in the group. That's how the common nomenclature works. And the 3 methyl groups are attached to a tertiary carbon. When there are multiple substituents present, they need to be listed in the name in alphabetical order. We ignore di, tri, tetra, anything that tells us how many of those substituent is present. So dimethyl would be alphabetized by M, triethyl would be alphabetized by E, etc. We're going to ignore hyphenated prefixes like N. We won't see that very often, but it stands for normal, which means straight chain, sec, or tert. Ignore those prefixes. Do not ignore cyclo or iso. Pause the tutorial for a minute and give this one a try. Write out your answer on a piece of paper and then come back to the video. Alright, let's follow our rules. We first need to find the longest continuous carbon chain. And it turns out that it's 9 carbons long. So this is going to be named as a nonane. We need to identify the substituents that are attached to the chain. I have a methyl, I have an ethyl, I have another ethyl, and I have an isopropyl. So all of these will be a portion of the name. I need to figure out how to number this. If I start on the left-hand side, my first substituent is on carbon 4. If I start on the right-hand side, the first substituent is also on carbon 4. So I continue until I find more substituents. Numbering from the left, carbon 5 is the next substituent. So numbering from the left, I would have an ethyl on carbon 4 and an isopropyl on carbon 5. But if I number from the bottom right instead, I would have a 4-ethyl and a 4-methyl. That's better. That's a lower number. So putting this all together, I'm going to have 2 ethyl groups. They're on carbons 4 and 6. So it's 4,6 diethyl, that's alphabetized by the E, 5 isopropyl, that's alphabetized by the I, 4 methyl, alphabetized by the M, nonane.